This video is an introduction to the series and parallel circuits magnetic mat electrical training system. I know it's a long name. The name is long and tough, but the circuits that we'll be diagnosing here are going to be pretty simple. So this magnetic mat is used as a tool to be able to train students how electrical circuits work and to better understand and diagnose those circuits. So there's several other mats that we'll be covering in this series, but this is the one that's the second mat that students will encounter. The first one is the Ohm's Law Trainer that talks about very basic electrical voltage, resistance, and current that's found in an electrical circuit. This mat is intended to be a training for series and parallel circuits that we would find in a lot of automotive applications. So I'll introduce the different nodes. Those are the components of the electrical mat, and then we'll be doing further lessons as we proceed through learning more about series and parallel circuits. So the first node that goes into this is the power supply node. This is an outside node. I like to think of it as not part of the circuit. It's going to electrically provide energy to the batteries, but this is simply just a device to be able to make the batteries a little bit smaller and not take up so much space on the magnetic mat. The power supply has 8 AA batteries inside, and it outputs approximately 12 volts. The back of the power supply has magnets so that you can attach it to any metal surface. We utilize this on whiteboards at Weber State. The next thing that we're going to add to the mat are these wires. So these are banana jack wires. They're simply just a way to be able to transmit the electrical energy to the various nodes found on the board. So your kit should come with 2 red ones and 2 black ones. These top wires, I'm going to go to the top battery, and the bottom 2 wires right here we're going to provide for this battery node. As mentioned before, similar to the power supply, these have magnets here on the back that helps them hold them into position here on the desk. But if I were to utilize these up on a whiteboard, it would hold up to the whiteboard as well, as will this mat itself. So we get our electrical energy from the power supply. This battery node is a simulated component, meaning that the electrical energy doesn't really start here as it would in a traditional electrical circuit. We wanted to decrease the size of these nodes in order to make it a little easier to provide the instruction on here. So when we're looking at the circuit, we're going to treat these batteries as the origin of the source of electricity, even though that happens over here in the power supply. I'm going to add, this is just for filming purposes, I will be adding a set of banana wires from an external power supply. This just keeps the voltage consistent while I'm filming. You won't be utilizing this external power supply. If you did have at your facility, if you did have a way to produce 12 volts, you could bypass this red power supply and utilize that as your setup. The battery nodes will indicate a voltage value. These are fairly inexpensive meters, so their accuracy isn't going to be exact. Even though I'm providing the exact same voltage to both these batteries, you can see there is a variation. The variation isn't significant enough to matter in our diagnosing of the circuit. It's just something to be aware of when that doesn't necessarily match exactly what your meter is showing. I'll be using this Fluke Series 5, or a Fluke 87 Series 5 multimeter. This is one that was recommended by GM for their training classes, as well as through technicians and dealerships. I'm most familiar with that meter. There's lots of other meters that you could utilize to be able to do this, but that's the meter that we will be using here. It has the ability to measure both volts, ohms, and amps, and that's the main priority of this training session. But any multimeter is probably going to be sufficient to be able to perform these tests. The next thing that we'll add here is this node right here. This is the fuse node. The fuse node contains a traditional automotive fuse. So you'll find these on most vehicles still utilize some type of a fuse. That is a circuit protection device. It's used to be able to protect the circuit from overcurrent conditions. So a situation when I have too many electrons moving through the circuit, I don't want to cause a fire, and so the fuse is meant to fail under those conditions. The next thing that I'll add to the mat are these wire nodes. Rather than just have a simple wire that connected, like these wires that we used over here, I have these as nodes because we can actually set a fault in each of these wires and simulate a problem with the wire. So I could set a fault in this wire to have an open or high resistance, and that can help us in our diagnosis. And so that's why they're in this node. Plus then it keeps it nice and organized because these are magnetic and they're going to stay in the right position. So I have several more wires to add. The wires other than that are just traditional conductors that provide a good path for the electricity to flow through the circuit. I have these kind of unique, at least this is unique to this training system, these three nodes. Two of them are called splice, and this one up here is called a splice-LT, a splice left. So we'll go over this more when we talk about a parallel circuit, but these splice nodes are simply just a means of branching out the electrical paths that the current can travel down. So we can come in one direction and then leave in multiple directions. So this allows me to set up a parallel circuit. This splice left is utilized as just simply as a wire, although it has a place to be able to connect something up here. We're not going to be utilizing it for this lesson, but in future magnetic mat videos we'll be looking at how that splice left can be utilized. Next we have the latching switch. So this is the red latching switch, and I've kept these colors separate so that we can kind of see them as different. They serve a different purpose. Black is battery nodes. Red is some kind of a control node. So we have this latching switch, and in the kit it also comes with a three-way switch. And then these gray nodes are indicators of that they're simply just a wire, right? I'm passing current through the circuit. The latching switch is a switch that I can depress once, and that is going to lock in either the on or the off position, and then I can remove my finger and I no longer have to press that. The latching switch is in the off position when the button is fully up, and then when I press it down, it mechanically locks into the on position. So I can release it from the on position and it can stay in the off position. An example of this type of latching switch that you might find on a vehicle is a hazard switch, right? You press the hazard switch and it stays in the depressed position. The other types of switches that we might find in a vehicle are a momentary switch. This is a switch that requires me to continuously press in order to keep the circuit on. A good example of this is the horn switch. So when I press the horn, it stays honking until I release it, and so it doesn't stay on. Luckily, I know some people probably would want it to stay on, but it doesn't stay on permanently when I depress the switch. Okay, so the final node that we need to add to this circuit is the load device. So the load that we will be using in these circuits is an LED, a light emitting diode. Whoops, that one goes up here. I've got two different colors that I use for this, a light blue color and a dark blue color. You should also recognize that they're different sizes, and there's a purpose behind that. We'll go into that in further detail when we start talking about voltage drop testing and doing other diagnostics, but they are to simulate different parts or different types of loads that we might find in the circuit. A load device is simply the thing that's supposed to be on when the circuit is on. So in the case of a light, it should turn the light on. In the case of a motor, when the circuit is on, the motor should turn. And so these load devices, we use LEDs because it'll be a very basic way to diagnose circuits, as well as a lot of modern vehicles are going to contain LEDs, and it's important to know some of the characteristics of an LED. These specific LEDs are bidirectional, meaning that the polarity of the LED does not matter. So let's see what that means. So right now I have this LED in this location with the red jack on the right side and the black jack on the left side. If I disconnect this LED and I rotate it around and put the red jack on the ground side of the circuit and the blackjack on the positive side of the circuit, this LED still illuminates. A lot of basic LEDs will not operate like that. They are sensitive to the polarity of the circuit, meaning that the one side of the LED needs to have the positive side of the battery connected to it, and the other side of the LED needs to have the negative side of the battery connected to it. So these LEDs are bidirectional, so we don't need to worry about that orientation, but I want to make sure that you understand that not all LEDs act in that way. So now we have our circuits. We have both our series, which is this top circuit right here, and our parallel circuit, which is the bottom circuit. We'll be utilizing these in future labs to be able to discuss the different techniques that we're going to use when trying to figure out what's wrong with the circuit, as well as some of the characteristics of the operation of a series circuit compared to a parallel circuit. So hopefully this magnetic mat system works out well for you as you continue on with your electrical training. Hopefully you'll be able to get some hands-on experience with these as you continue to work through the labs. Good luck.